Now the problem is that sometimes they give us different assignments of probabilities, or different probabilities for our outcomes in the sample space. Let's take a simple experiment. Here I have a bag with some red marbles and some white marbles. And we don't know what's in the bag. And let's make some empirical evidence and assign probabilities based on that evidence. So the sample space for our experiment, some of these marbles are red and some of these marbles are white. And my experiment is to draw a marble from the bag and observe the color. I have two possible outcomes, and I'm going to assign probabilities based on empirical evidence. So I'm going to repeat this experiment 10 times, and I will assign to each of these a probability equal to the proportion of times that I see that color. First one is white. Put that back in the bag, shake it up a little bit. Next one is red. Red. Shake everything up a little bit. Red. Shake everything up a little bit. White. Shake everything up a little bit. White. Red. White. Two more to go. White. And lastly, I get a red. So out of these 10 outcomes, I have 5 reds and 5 whites. So I'm going to assign a probability of 1/2 to the red and 1/2 to the white. So as far as I know, there are equal numbers of reds and whites in the bag. Now if I actually look and check, it turns out that there are 6 reds and 4 whites. So now that I've looked, I know there are 6 reds and 4 whites in the bag. And knowing this, I would assign a logical probability to these two outcomes of 6 out of 10 and 4 out of 10. So we see we got a different assignment of probability from the empirical evidence as opposed to our logical assignment of probability.